Sir, live started, sir.
Fine, ma. Proceed. Okay.
Good evening, one and all present here. Today we are gathered here for World Energy Conservation Day celebration from the Institution of Engineers India, Tiruvallur Local Center. We cordially invite you for the week-long celebration themed as World Energy Conservation Day. Now I call upon Dr. L. Ramesh, Chairman of IEI Tiruvallur Local Center, to give a welcome address.
Thank you, Tejas. It was very happy that we under the new leadership of the new team, we started our first Conservation Day program. It is a continuous program, and happy Energy Conservation Day week celebration. And it is very happy that so unfortunately the people connected together to work for a green, which towards the energy conservation. Keeping in that mind, we started connecting some bundle of programs. In that bundle of programs, today it is the 29th technical lecture. We connected with the series also. So the next couple of days, the program will be connected through for the Energy Conservation Day, but it will be like a series of lectures, seminars related to the Energy Conservation Day. I'm very thankful that today we have our good friend and speaker for us, Professor Mohansundaram, Dr. Mohansundaram from KPR Institute of Engineering and Technology and the Director of IGEN. Welcome, Mohan, to share your experience on energy and related activities so that it will be helpful for the people and the audience. And I would like to welcome our chairman, past chairman, Jairai sir, and the governor or past governor of Rotary Lions Club.
Lions Club, sir.
Lions Club, and also the association secretary, sir.
Engineers Association Vice President, sir.
Vice President, okay. Like that, I can tell continuously lot of designations. Like sir also doing lot of activities, social contribution activities, and welcome our secretary and all the participants for our program. Thank you so much. Thank you all.
Now I request Dr. Jayarajan, past chairman of IEI Tiruvallur Local Center and superintendent of Tamil Nadu Electricity Board, to give an inaugural address.
Thank you, Judges. Good evening to all. As you know, today's world is running by energy. Each and every activity is require energy in one form or other. 1% of energy is getting from thermal power stations by burning fossil fuels, and the balance from hydro, nuclear, wind, and solar. By burning the fossil fuels, we are polluting the environment with the emission of CO2 and other greenhouse gases, which are responsible for the increase in the atmospheric temperatures. If the temperature goes on increasing, the planet would become unsuitable for human habitations. So the United Nations are decided and derived Sustainable Development Goals. 17 Sustainable Development Goals they derived and implemented for the benefit of the future generations. The world is celebrating international, observing, not celebrating, it is observing World Energy Conservation Day from 14/12 to 21 and 2011, 2021 to 12/21. And energy conservation, create an awareness to the public and to save the planet for our future generation. On behalf of IEI TVLC, Dr. K. Mohansundaram, Professor KPR Institute of Technology, has kindly consulted to give a lecture on energy management of inverter and battery on renewable power systems. I wish all the participants to actively take part in the program and implement in your day-to-day activities to conserve energy and water. With these few words, I thank Dr. L. Ramesh, Chairman IEI TVLC, and Dr. J. Balamurugan, Honorary Secretary, and all other committee members for giving me this wonderful opportunity to inaugurate the week-long program on Energy Conservation Day. We all work together, save energy, save water, save the planet. Thank you, one and all.
Now I request to Dr. K. Mohansundaram, sir, Professor EEE and Associate Head Center for Research and Development, KPR Institute of Engineering and Technology, to brief about energy management of inverter and battery in renewable power system.
Is it audible?
Yes, sir. It's audible.
So thank you, our Chairman, IE Chairman, Dr. Ramesh, and then thanks Dr. J. Balamurugan, Secretary, IE Renewable Chapter, and then I would like to thank our Ganesh Jayarajan, sir.
Your voice is not clear, sir. Please.
Yes, is it clear now?
Okay.
Yeah, okay. So thanks, Ganesh Jayarajan, sir, past Chairman, IE Renewable Local Center, and then Chairman, Dr. L. Ramesh, and then I would like to thank our beloved Secretary, Dr. Balamurugan. So as we are celebrating this Energy Conservation Week from December 14th to December 21st, as the topic, it will be like energy management of inverter, and then how this battery management has been done when the renewable power system is tie up. So that is our main hot topic. So let us discuss today what is the importance of energy management. So I will share my screen. I hope my screen is visible.
Yes, sir.
Okay, thanks. So that is like the topic is energy management of inverter and battery in renewable power system. So myself, Professor Mohansundaram from Department of EEE, as well as the Associate Head for Center for Research and Development, KPR Institute of Engineering and Technology. So something is happening on my screen. Some scribbling. Okay. So what is meant by energy? As we know that the topic is like including that the energy management and conservation of this inverter and battery in renewable power system. Okay, how we are connecting with this inverter and the battery, or when you are connecting the renewable power system, say for example like PV system and wind system, how we are going to improve the gain of this converter in such a way. So we'll have some 2 case studies related to why it is very important this energy conservation as we are celebrating for this entire week. It's very important how to manage those kind of inverters and batteries in a tie with grid connected with your renewable power system. So what is meant by energy? As we know that energy is capacity to do work. So without energy we cannot do anything. Without energy we cannot power all your vehicles, or we can run our machines in almost industries. Almost in second part it can be used for some cooling our homes, like we can use it for our cold or something like steam, everything. We can even you can enjoy our music also. So this everything we need an energy. So the energy, as we know, that is the ability to do the capacity to do the work. So it is like a mandatory one It's very important in what way we are using this replacing and how we are getting this energy is very important. So as we know that the place important, like it is like an essential service in the modern world. We can use it in every day, almost all applications, starting with your transportation, and then in almost all in agriculture sectors, personal comfort, or less like in communications, or since all kinds of like entertainment, in all kinds of your videos and everything like playing music. In almost all sectors, we could see this energy plays a vital role, and it's very important commodity. So that we have to take care of this energy. So how we are generating this energy, how we have to do for conservation of this energy. So these two parts are very important. So these are the two verticals. So the getting the energy is like in different waves, different forms of energy. We'll discuss, and then how we are going to utilize this energy. How can you go for optimization? How will the conservation of this energy in such a way so that it can be used for our better things. So as we know that the energy can be classified into two types, like renewable energy and non-renewable energy. As our past segment has saying that the use of coal and then these fossil fuels. So we have to shift towards the paradigm of renewable energy with the usage of renewable energy systems, renewable energy sources such as the solar and wind. So or maybe like small kind of from our biomass also. So this kind of energy plays a vital role as per our UN Sustainable Development Goals. There is 7. The goal number 7 is specifically for this utilization of this renewable energy. So the way how we are replacing this energy, renewable energy, is available plenty, but the way how we are going to utilize is very important factor to be considered instead of going for this non-renewable energy sources. Maybe as we know that we have a thermal power station that we are burning all kind of these coals, and then it may be like critical to the human life in for like almost all in eastern area of eastern Europe, as well as in southern parts of the China, as well as in India. We are moving towards this conversion of this non-renewable energy to the renewable energy. As we know that is like in hazardous going for this kind of non-renewable energy sources. The way how we are extracting power. So what is the alternate energy sources? As we are pointing about the different forms of these energies, like wind energy, solar energy, hydro energy, and then the tidal energy, as well as the nuclear energy, and then the geothermal energy. And nowadays we are getting like more kind of new energy, new forms of energy, maybe like maybe like the friction energy, like small kind of thermal electrical energy, how the waste can be converted. So in all kind of forms we can get like energy sources, how this waste heat can be used for the conversion of this energy. So this predominantly we can see that these alternative energy sources nowadays we play that is a very important factor, how they are contributing to the world in such a way we can use like utilize the almost all the energy sources from the wind, hydroelectric, and then solar energy, as well as tidal, and then the small part maybe like from geothermal. Okay, so these kind of things is like the alternative energy source, like also the biomass energy. So as we are speaking about these energies, like we have these three things like non-renewable, the alternative. We have to go for alternative. Alternative in the sense nothing but existing fuel, fossil fuel will not be like considered as an alternative energy. So we have to move towards the renewable energy. So as we are pointing about this, we keep on speaking about this renewable energy. The way how we are going to implement this renewable energy is very important factor. In almost all application, we could see that we can find that almost the solar and then the wind plays a vital role in the usage of renewables, particularly the solar. Now you can see that the unit per cost of this tariff will be getting reduced in the case of the solar compared to like last 3 years back. So that paves the way for the importance of utilization of renewable energy. So particularly with respect to the solar energy. So it's come from naturally. So the way how we are taking this renewable is very important factor. So maybe like we'll boost the voltages or the power in such a way. Maybe like being electrical engineer, we should go with the different kinds of modeling of this inverter and converter, those kind of things we'll choose in such a way. Maybe like we can get like more amount of power, so that can be utilized for our all kind of applications. Maybe like we are saying that maybe like our solar system or summer system will get like 30 to 40% of efficiency. So how our being an engineer, how we can utilize to get back to the 100% efficiency, that is very important factor to be considered. So that's why we are paying the way for conversion of this non-renewable to renewable energy. So, right. So as we know that we have to conserve this energy. So the conservation energy, we are producing energy. The next one is coming to the mind is nothing but yes. Yes. Okay, now it's fine. So this may be like digital environments, we will get some kind of maybe like disturbance. Okay, so why we to conserve this? Like we have limited resources available on the earth, as we know that there is very limited resources. So we have to utilize in proper way. We have to conserve everything. We have to save. So saving energy is a very important priority. That's why we are celebrating for this entire week. How to save this energy? If we save this energy, so it can be saving the energy in the sense like we can be saving the for the individual as well as it contributes. All the individuals will be contributing to the country. So that's why the demands is keep on increasing, as we know that the population is keep on increasing. So it's main important that in someday with I mean like renewable resources will be completely exhausted, and then we have to particularly move to the alternate energy, maybe like the solar energy or maybe like wind energy. So in that way, how we utilize these resources, how the renewable resources, in what way, when you're utilizing, when you're freely depending upon the renewable resources, maybe like your solar or maybe like your wind energy, this optimization is very important factor. So how we can utilize this energy resources, we'll see later. Like I'm having some case studies, so that can be used how we are optimizing, how we are getting the energy efficient by using the inverter, and how we are able to manage this with respect to the conservation. So we save, as I told, I already quoted, like we can save our money when we save the energy. So there is a basic funda behind that one, and then almost if we go for that, then automatically clean energy. So in such a way, we can go for the reduction of this pollution. This is very important primary factor to consider. So we being a human being, we have to live for 100 days. We have to give for another generation. Maybe like another generation, we need to reduce that pollution. That is very important. So that sustainable lifestyle is very, very important. So we save energy when we save the energy. That is the behind that one. So this is the energy pyramid. Like we are conservation, and then the efficiency, and then the renewable energy. We have to keep on using the different forms of this renewable energy. The conservation is a very important factor. So the utilization of how we are replacing these energy efficient devices, that is very important factor to be said. Maybe like star rating, which plays a vital role in the home applications. So that's why we should go for high star rating devices. That is very important factor to be considered being an engineer. So at home we know that we cannot keep light unnecessary. So like that's the thing. So we can reduce the energy. So based on that, we'll have like small kind of energy conservation we can remove, and then we can utilize the water heating efficiency. We can go for different kinds of maybe like IoT devices. Now they keep on incorporating everything. We can reduce the speed of that particular fan, or we can go for different kinds of input energy efficient fan, maybe like the VLDC fan, that super fan, they'll say that super fan, energy conservation fans. So these things, like also in public places, we can switch off the fans and lights in bus terminals, or we can switch off the street lights whenever it is required. So this kind of any innovation technology we can bring back, as we are having so much of audience. Maybe technically they are sound. We can think of that how we can optimize these kind of things, so that we can save our energy in our public basis. That is a plays a vital role. So the energy conservation, as we know that 70% of India's energy conservation is from as our chairman, also past chairman, pointed out that we are taking from the fossil fuels, the coal accounting for 40%. So in maybe the country like India, when you are going for the year 2030, maybe the depletion of these things will be happening, maybe like the fossil fuels. Then we have to really come back to the different kinds of energy sources, maybe like the electrical, like the renewable energy. So maybe this may be some of the basic statistics they may be giving, like why we are using energy conservation in India. So as we pointed out, what is the basic difference between the conventional and renewable energy sources? So here the hot topic is nothing but we'll go with energy management with respect to the renewable power system, how we are effectively using when it is connected to the grid-tied power system. So we know that the conventional energy sources on the left hand side, we know that the fossil fuels, nuclear fuels. So all this will create the atmospheric pressure. It's not like in clean energy, whereas in compared with the renewable energy sources. So renewable energy sources provides it provides a clean energy system, and it provides zero pollution. So as we know that the end of coal is coming 3 times faster than expected. So what is the report in the 2022 integrated system plan? What they have the energy policies. So almost in Australia, they are planning their they will plan to shut down all kinds of these coal generating power plants. So maybe as new policies may become, even some industries and government will be surprised. So that why we can go ahead with your reaching that UN Sustainable Development Goals. We can do the way for other generations. So the end of coal is increasing very fastly, so that we can expect it. So almost all we can go with renewable energy sources. So we are standing in the fifth position, renewable energy scenario. This is with respect to the entire world. So in fourth position, and then this we have starting with respect to the 2018 and 2019. So the importance of this utilization of the solar power strands remains we are reaching the target very soon. Maybe we reach around some 150 gigawatts. So this picture shows that we are on par with working towards the renewable energy sustainable development goals of SDG goal number 7. So our target in 2022 175 gigawatts. We are almost nearing to this one. So for 156 gigawatts has been reached. So almost 6 by 6, or maybe from nuclear, and then almost 150 maybe from these renewable energy sources. As we are planning for 100 gigawatt from the solar side, and then 60 gigawatts from wind side, and 10 gigawatt from biopower, and then 5 gigawatt from small hydropower plants. And we are having small of conversion of these rivers, how to convert those kind of things into a useful utilization of energy. So that's maybe the 5 gigawatts from small kind of hydropower plant. So this is the target. We are on par. We are reaching this target, maybe 100 gigawatts. This is reader. You can see that the last first India added over 7.4 gigawatts of solar power capacity in the first 9 months of 2021. So that's an 335% year-on-year increase compared to our last year. The same period 1.73 gigawatts. So this is increasing when the trend is the graph is increasing exponentially, so that we'll reach that our target of 175 soon by 2022. So this may be with respect to the different kinds of the solar projections off-grid solar, maybe application 2000 megawatt for rooftop. So residential and commercial 40,000. So our MNRA has supported many projects, particularly in Maharashtra, for implementing these rooftop projects. And then for large-scale projects like solar parks, 20,000 megawatts and 50,000 and 40,000 megawatts. Recently, we could see that this kind of erection of the solar power plant in also in our CRD also already. So they are planning to erect all kind of small projects. So these are some of the how we are replacing our solar panel different way, the way the innovation technologies. How you can replace maybe like the floating solar plant or maybe like the over the canal, and then maybe like for agricultural purpose, how we can replace this solar energy. That is very important. So maybe like we can use it for railways. So as we know that this modernization of both advanced developing countries, energy needs is very important factor. So the way how we are taking this energy is very important factor. So this slides shows the how we are projection towards the for 2030. So there is a rapid growth. There is a tremendous increase in replacement of renewable energy, almost 40% of whatever we are having right now. Maybe right, we are replacing fuel from renewable energy sources. So as we know that like the today's technology components, like the major things like engineers, we have in the good kind of engineers, so they can develop new energy systems. You can see that the energy for that is a new company, that's a small startup company, how they are generating the energy from the friction. Everything they are able to do it. Maybe like I will show you the video how the technology is booming like anything, how they are taking the energy from small kind of innovation they are doing. So that's very important. Like being, I mean, like we will have so much of audience which watching to us this thing. Like we can have that how the various method, how the innovative methods can be utilized. The sense of like how there can be energy storage, how there can be conversion, how this can be transported. So these things are very innovative. It plays a vital role with respect to the engineers to develop new systems. So this may be like our today's grid. Like we'll have like all this combination of this the wire systems. Everything will have like the traditional power generation system. Maybe like the grid. How they are. This may be like the common things like we'll have like generation, transmission, as well as the distribution. So maybe like the tomorrow's week is like an integrated thing, like where maybe like centralized. Maybe we can use this blockchain technology also. In such a way, we'll have like isolated microgrids or maybe nano grids or like small kind of this solar powered EV stations, particularly for our EV vehicles, and then this for commercial buildings and then for reference. So this may be like our tomorrow's goods. We can replace all kinds of all renewable systems. So when you're integrating with this, maybe like the central power system or maybe like tie up with the power system, then there'll be we are facing so much of the problem, the way to unbalance everything. So that being a technical engineer, how should we should I mean, like handle those kind of these imbalance? That is very important factor to be considered. So this is like emerging markets. I guess as already so that we can see that like we are reaching almost this 175 gigawatts. Maybe like in a couple of maybe like in 2022 we will achieve this goal with major contribution from the renewable energy sources. So as the people are moving towards the appreciation of this, particularly this solar energy, so there be a huge vacancy, like we can see that huge job of this, particularly in the world. We could see that almost like 24 millions will be needed for this whenever reaching like 2030, as we are promised to the UN Sustainable Development Goals. Like we can utilize, then there will be a tremendous increase in like appreciation of this renewable energy, particularly this solar energy and wind power. So this space, like there is a huge opportunities for the engineers. So what are the moments why we are going for this renewable energy, like maybe like fossil fuels, maybe the end of it, maybe we are getting like as we are getting there more number of that health problems. So then we have to go for this alternate, that is reducing air pollution and improving public health. That is a very important factor to be considered. So that we'll have that energy security as well as renewable, the importance of the renewable energy. That is very important. And then, of course, when I'm going for this sustainable development, so this plays a vital like three-pillar model, like the environmental, the culture, and economic, the techno-economic analysis, and how it can be placed for the this like for the society. So this is very important factor. Is very important factor to be considered. That's very important. Sustainable. So this already we are seeing like it's increasing cheaper than the new and existing coil. Maybe like I told, like the cost of this utilization of this solar power, I mean, like per unit cost will be getting reduced. So maybe we are expecting still further reduction of this unit. So then automatically all the people will be keep on moving to like maybe like standalone or maybe like the grid connector. So this paves the way how these people are moving towards this renewable, particularly the solar and wind energy. So maybe like the services provided by PV systems, maybe like the technical services like the data power control, active power control, and grid forming. So these are the entire PV system things like we have in the model, and then the battery storage system, the inverter, and then we can connect back to the grid. So here, when I'm talking about this model, we have like kind of all kind of this modeling factor is very important factor to be considered. This PV modeling, how can effectively utilize the power from that solar energy, and then how we are taking the power, how can it place back to the grid. So this is like the complete sketch of how we are planning for this single phase PV grid systems, as we have in like all kind of the controllers. Like this, we are done with small kind of case studies along with my research scholars, and then we came to that we are done like some small kind of thing, how we can utilize the maximize the efficiency of the particular this from this PV grid systems. So the way of how we are designing the inverter is very important factor. The boost converters also plays a vital role. Okay. So I mean like the controller also. So we are using like all kind of the new innovative like ANN based techniques, everything how to optimize in such a way so that the controller gain will be keep on increasing, so that I can it provides a continuous power supply. That is the main factor to be considered. So these are some of the different topologies like PV grid inverters, like we are having like voltage source inverter and current source inverters. How we are handling that multi-level series. We will see later like how this can be connected in different forms. So as a basic fundamental, like this is like a classification of this multi-level inverter, like the single DC source and separate DC source, diode, clamp, and capacitor, which belongs under single DC source. And then the separate DC source will have cascaded HDs inverter, so that we'll have like different kinds of resistor source inverter. We have made like a new kind of thing like switch DC source converter, which plays a vital role in improving this power factor, like everything, all the control gain also to be keep on increasing. We'll see later that in different case studies how we are implemented, what is the objectives, and then what is the thing we have achieved. So based on that. So the traditional two-level inverters is just multi-level inverters. So first, before going to this, why we are going for this multi-level inverter, like there should be a comparison. So being a researcher, being like any kind of like any startup, going like I'm going to implement my multi-level inverter. So why we need a multi-level inverter? That is the first thing. Like why it's running on two level. Why we have to change this multi-level? So what are the prerequisites or what are the constraints? Okay, so how it is advantage. So if we have this look on this one, where we are taken like the factors, various factors that we will be considering, like the switching loss will be like having the two-level inverters will be like high when I compare it to your multi-level inverter, maybe like it will be like low. So the dV by dt, so of course it's high in the case of this two-level. So these are the parameters. Like you can see that on the left hand side we have this more important voltage stress will be more. So when I'm going for this kind of multi-level inverter, then automatically the stress will be less, the frequency also very less, and then the level of output voltage is very high, as we know that it's like a multi-level inverter. So so that the third part, like it's very important factors, nothing but the hormones. We have to reduce these hormones. That's also is maybe placed better when compared to your two-level inverter. So this is like a basic thing. So as an engineer or like any energy conservation going like kind of things, you can implement why we need this multi-level inverter. So this is like a technical component which plays these factors, what we are considered as very important factor to be considered when why we are shifting to these multi-level inverters. So maybe like when are going for this multi-level inverter, they will be like as we pointed out, there's different network structures. We'll have like diode, clamp, and flying capacitors, and then we have a cascade and multi-level. So what is the advantage? Why we are, I mean, like disadvantage? So these things like plays a vital role with respect to the efficiency. Maybe like we can get like high efficiency, but when it have some certain disadvantage also. The real power flow control for inverter is very difficult. So these kind of things like plays a vital role. Being an engineer, we should know why we go for these different kinds of this inverter topology, particularly with respect to this MNI. Okay. So this will be like your cascade and multi-level. So why? So after the basic thing like why we should go for this Z source inverter, and particularly in application in solar and this. So we know that Z is a combination of like the combination of the inductors and the capacitors. So it can be operated as like in voltage source inverter or maybe like CS the current source inverter, depends upon the application, depends upon the load. So maybe like the output voltage, like it varies from 0 to infinity. And then, so this we can like the solar models widely preferred for residential as well as for commercial. So we can make it like in parallel or series combination to form a model. So we are making like different switching off this Z source inverter. We will plan for conducting like Z switch source mode so that we can reduce the switching force THT level also we are planning to reduce this kind of things. So the main concept behind is nothing but we have to develop an economical and efficient PV system. That is very important. So as we pointed out this PV inverter bit structures, this like inverter portion plays a vital role, like the boost circuit and built out. So into a system in order to conversion this DC to AC, Z source like intelligence choice. So Z source inverter plays the people are doing all kind of researches in how we can utilize this Z source inverter. So particularly it can boost the voltage level with very compact structure. That is a main advantage of this compared to ordinary kind of inverters. Say for example, like for 10 kilowatt PV system, 20 kilowatt inverters required with the traditional inverters. But whereas when using this ZSI, so 10 kilowatt inverters, maybe like we can need a 10 kilowatt PV system. So the same kilowatt ampere is maintained. So we should not go for extra 20 kilowatt inverters. Okay. So that maybe like these traditional inverters maybe like poses some challenges in their control or maybe like modulation mechanisms. So these kind of things can be eliminated or eradicated by using this kind of Z source inverters. So maybe like the topology will have like different kinds of these transformerless and with the transformer coupled inverters. So it is the two things. So again, like why we are going for this Z source, why we are having even for this Z source, we will have different configurations, the different topologies. Like we starting with the research source, this normal thing we use only one diode, and then the features maybe like we can have discontinuous input current. Maybe like with respect to the positive source, we need to one diode, and then include is source one, and then semi is source we will have different ones. So these like being technical specifications, we have like an idea why we are going for different combination of this source inverter, and then with respect to applications. So this will be like a continuation, like different kinds of again the network structures. Maybe like we'll have a different combination of this. Maybe like different applications, different features. Like we can reduce the number of the semiconductors, active semiconductor. We can improve the buck boost capability also, and then the high power density also depends upon application. And going for different applications, maybe like electric vehicle applications also. So these way, like we'll have different configurations. So this can be used for different applications, and then the different sources. So this slide shows like we'll have like different combinations. Why I am showing this kind of this slides means like being a technical engineer, you should know why. What is the importance? Why we need an research source compared to different kinds of sources, and then how it can be utilized in proper, how it can be boosting the gain of higher gain, how we can achieve that based on your duty ratio. That is very important. So this is like in continuity of this thing. So so this picture, like I'm saying a courtesy for this ABP. So like we'll have this entire system, how we are replacing that for different applications like the grid applications, how we are replacing for this, like taking the power from the renewable energy sources, how we are connecting the grid. So this may be like for small scale applications, maybe less than 350 kilowatts, or medium scale less than 10 kilowatt, and then for less than this center. So we'll have different configurations like MOSFET and MOSFET IGBT and then IGBT. We'll have like all the pros and consequences, like how we are replacing like flexible mode, or maybe like we're going for grid efficiency. So that is a thing where very important, like coming for different applications. So why we are having this configuration, this like kind of things we are done like a survey, and then we can come up with the solutions, like we are going with new kind of configurations, like maybe like switch resistance source configurations. So this slide shows that how we are synchronizing the methods with respect to the single phase and three phase, maybe like we'll have like open system and closed system. So this may be like the basic fundamental things how we are adding this. Okay. So these are some of the specifications with respect to the international code, how we are placing for this grid connector, maybe like with respect to the different category like off-grid and rural system, particularly for LVRT and anti-isolating. So these codes are specific international codes, and then the area of amplification where it can be placed for better system, maybe like for the standalone system, for the off-grid system, for rural system, maybe like medium scale systems, particularly with the renewable system and the hybrid system. Okay. So why see when we are taking like optimization effect, that is very important factor to be considered for treatment of uncertainty. So nowadays the people are, we are moving towards the digital area. We are replacing all kind of AI techniques, how we can get like the variables, like how we are taking the mathematical modeling, like PV modeling is a very important factor when they are buying a PV model. So maybe like whatever the data sheet they are providing is nothing but for the standard temperature operating condition. So here we are having the temperature will be keep on changing, and then the irradiation will be keep on changing. So we should have an awareness how we can model the system with respect to the entire system, with respect to the MATLAB, how we are going to do. So that those things are very important. So this optimization plays a vital role, which provides the how we are using this website optimization constraint with respect to the parameters to be considered. So maybe like we can go ahead with their minimizing the P losses and doing this different kinds of automation tools, control variables, and maybe the distribution or system. So these are some of the basic things we are done, like some survey we are done like literacy survey. So why we need an optimization technique to solve our particular problem. So these are some of the slides which shows that how we are controlling techniques can be used. So the slides like so we are done like small kind of contribution like with along with my research college. We are done like for the grid connected hybrid energy system, which can be realized by separate voltage source converters like switch resistance converter, and then there is a battery backup also. So we need a continuous power, that is very important to the grid. So here we are having like independent system, whereas the control of MPPTM will be performed by PA controller. So first we are, as a basic researcher, I will be plan to conduct through this PA system, PA control system, and then later we are plan to implement this ANN control, and then we can maintain this constant voltage. That is our ultimate aim. So here we are converting, we are replaced, as we already told that, result source converter. But here we are making like a small modification, like switch result source inverter is deployed to analyze system stability and then the effectiveness of the overall system. So we have developed like all mathematical modeling, and then we are done like applying this result source converter, and then we can find that how this overall system can be improved by developing this system. So, being like why we should go for this this converter? Why we are having so much of this converter? Like as we know that we are having so much of converter that is existing, like SP converter to PSP, and then PSP, so small PSP converter. So Last column shows that our converter, like the proposed current converter, how we are using the switches, like one switches and inductor 2, and then here the ultimate the key component is here we are using the 3 capacitors, and then the boost factor. You can see that almost all these factors, the point for 0.3 duty cycle, the gain of this output power, you can see that the boost factor is almost 10, which plays a vital role, and then also the voltage gain, which we can achieve that 7.8. So these kind of converter propose like we can utilize this energy in maximum thing, so that we can give back to the power to the application. That is a very important factor to be considered. Being a researcher or being a like an academician, we are working on this one, how to improve this system. So we are getting the energy, how we are converting this energy, how we are boosting. That is a very important factor. How the people are working that, how can boost their output voltage. That is a very important factor to be considered. So here we should see that we can have the entire column. It plays a, we are having a confident, we are having enough proof that, so this proposed converter will provide an excellent performance compared with the existing systems or existing converters. So this is our, we are done like the entire system. We are, this is our new kind of converter, the boost converters. So we are done like 3 systems like the PV system and the wind energy systems along with battery management. How we are effectively the energy management has been done with respect to the gain and base control, and then we are paying the output to the grid. So that is a very important factor to be considered. So here we can see that we are applying these 3 capacitors and then 2 inductors, and then we are improving this boost factor, boost and gain factor. That even for the duty cycle T on divided by T on plus T of time, even for small time also we can get the efficient output. That is a very important factor. That is we are done with the simulation results. Also we are done with the small kind of experiment results also. So this is like conversion resistor source converter, switched resistor source converter. Yes, is that yes. So based on this, we can achieve our output. So this like we have made like a comparison, like how we can with the use like the PA controller and like the fuzzy controller, and then we can see that the different values of output we can compare it. So this like we made a like a comparison. So as output to make a justification, like how these intelligent techniques can be utilized for the control of these things. So what is the inferences from the case studies? Like we could see that the flow of power is very continuous, like a dynamic is using like research source converter with the grid. So maximum it can be used with like 3-phase inverter what we are designed. So this is the kind of work we are done. And then so this is very important factor, the continuous power flow. So how we are balancing this energy, as the topic is we are given like energy management between like inverter and the battery is very important, like grid is very important. The source and grid is very important. So we are going to utilize using the battery energy storage system. And then most important factor like incorporating these kind of converters, then this TGST level plays a vital role. So almost the TGST level is will be below the IEEE standard levels. So that's proves the system can be very important converter to be utilized for our modern power systems. And then the proposed SVPAWM can be utilized to give enough DC voltage with the proper duty cycle control. And then thereby it controls the harmonics, right? So like as we are speaking about this, like I will just feel like how we have utilized for energy efficient. This is like a case studies. We are inferences. We have done the case studies, and then based on the case studies, we can see that how we are utilizing this power is very important. So the energy management is very important. So as a takeaway from today, like we should have like how this energy efficient operations, as we are speaking about like the different kinds of replacement of this energy efficient home appliances. It's use like the daylight as much as possible, and then we can go with the like LED, and then we can switch off the box like when it's not necessary. There is a third one, like switch off your fridge and freezer when there is empty. And then don't put on your hot or warm food straight away into the freezer. so that is take consumes more number of energy, and then defrost regularly. So and then use the fan like instead of air conditioner. Now we can go it like different kinds of fans I'm using, like starting with new fans like super fan, the same like BLDC fan, and then you can go ahead to keep the doors and windows in air conditioner or in operation. That is a very important factor to be considered. And then switch off your like condition, whatever the air conditioner leaving the room. That's place we can save the energy. So this electric kettle to boil the water instead of electric cooker, so that we can achieve like this kind of things we can implement. Like we can go at like when we're using the iron boss, we can utilize properly. Like we can use take all the clothes and second don't put on frequently using the iron boss. That's a very important. So don't leave that also for your water heater for a long time. So these kind of things like take away for our home application, being like for this energy conservation, we should take away for this we can we can practice for our youngster also, even for kids also. We should show the importance of how this energy conservation plays a vital role in our basis. So maybe like the next slide, I will have one more video, so that can be useful, like how this this small kind of conservation, the energy, how that generated by using a small startup company with response to the energy wall. It's very interesting. I think there is a new startup company. They came up with kind of different form of energy, how they are creating this energy. Okay. So with that, I will conclude my session. Is there any questions from audience?
Ija, please coordinate for us. Yes, sir. Any questions from Sir, no questions available, sir, in the YouTube chat box, sir.
Our speaker, okay, one moment. Today we have got another engineer who is from another association. So she is our favorite madam. So Tirupati Jayanti ma'am has joined. So her few words about energy conservation. So please, ma'am. Madam, I think madam is not there. So people, if they don't have any questions, we can close up. So it was a wonderful session by Mohansundaram sir. So clearing all such information, so connecting the energy pyramid. So starting from energy, that is generation of energy plus conversions of energy, and how simple we can convert it in our home itself, like installing solar panels. So that was a huge information which was pulled with soft corner speech. So he was so soft enough to put all his words connected with such a wonderful presentation. Thank you so much, Mohansundaram sir, for a wonderful connectivity, starting up with this solar and inverter model. So that is a wonderful opportunity. So we'll connect with another speaker by tomorrow. So there is a series of lecture starting from today. So starting with Mohansundaram sir, we have further lectures going upon. So please connect and enjoy this contribution. So today, at least we can take a oath saying that I am going to switch off at least one light at my ease that is not in use. In that case, that would be the contribution for energy conservation. So I hope people can do that. Thank you so much. So we can close up for the day. Thank you for the participants who have participated. So we can also connect more such people by tomorrow. Thank you, sir.
Thank you, sir. Thank you, Balamurugan, sir. Thank you all. Thank you all.
Thank you, Chairman sir, for allocating time in conveying his messages. Thank you, sir. Thank you all the participants. Teja, you can close up. Okay, then. Thank you.
Yes.